Right, so before I begin talking about this stuff, I actually want to mention, I don't know if anybody, if this has been helpful to people, but I put up all my lecture notes already to Piazza. It's in the resources. There's a section for, I think, Pollux notes or something. And I have notes now for lectures 12 and 13 that I'll put up as well. So let me just share my screen so I can give people a look at some of the notes I'll be putting up. Right, so lectures 14 and 15, the notes are still incoming because I just kind of watched the lectures so far. I haven't made notes on them yet. But I'll be putting up these notes on lecture 12 and lecture 13. So if you were looking to review any of this stuff, the notes might be a starting point. The one thing that I do want to mention about the notes, and I'll probably make a post about this on Piazza, is they are in no way complete. They're just kind of things that I wrote down while I watched lecture, which may or may not be things that, it may not have everything that you need to know from class. So I would definitely look at the syllabus, stuff to know from class sheet that I'm posting, as well as my notes. Because for example, when we covered encrypted email, I believe I wrote pretty much nothing about that because that's, even when I'm trying to write notes about things that are already things I know, encrypted email is at the point where I'm kind of not good. It's much harder for me to take notes about that. That would actually be useful to anybody in this class, I think. So just be mindful of that when you're going through my notes. And today we will talk about Tor stuff, or maybe I should just call it, oops, we'll just call it Tor today. Tor. All right, so what are things that we should know about Tor? First, we want to get an idea of the background, right? So what are the goals of censorship, right? And why doesn't data privacy get us all the way, which is why doesn't it prevent censorship in all its forms? And to understand that, one of the big things that you're going to want to understand, which Gabe mentioned right in the beginning quite a few times before we really dug into Tor, is this difference between data and metadata. So not only do you want, here I want to mention, you don't just want to know what is data and what is metadata, but you also kind of want to get an idea of what power does revealing our data give an adversary, what power does revealing our metadata give an adversary, right? The fact that we're all accessing the internet with our metadata completely in the clear. What's different about that to if we were going through, say, Tor, right? So get an idea of that. And along that same vein, I'm just gonna pull this up, is this IP-based blocking. So this kind of connects to this question as well. So maybe we can write it like this. These notes aren't organized right now. I'll probably organize them a little bit before I put them up. So if that's confusing, then know that that will be fixed. So right? So here, let me put a subscript here of like, think in particular about access to the internet. So when we're protecting against IP-based blocking, there's two things that we're going to want to balance at the same time, which is the fact that we need IP information. So we need IP addresses for routing, and IP addresses allow selective blocking. And so that's what we need to kind of balance these. We're going to want to balance these when we're talking about hiding IP metadata when we're communicating over the internet. And so what's kind of a first step towards hiding this IP data is just communicating over a proxy, right? So hiding IP metadata. And the first step to that is proxies. And I'm sure everybody remembers this part of the class, which is just, you could send a message directly to the server. Say you're in China, you're trying to access Facebook. If you say, then if you say that you're trying to connect to Facebook, maybe you're going to get blocked, right? And so instead, what you can do is you can route through a proxy. You can just go like this, and then you can say, we're trying to send this message to the proxy from the client. And so now a person looking at the message you sent out is not going to know where you're trying to go. And so that's proxying. What's the next step? The next step is mixnets. And so for mixnets, there's two different subparts. And the first part is the mixing, and the second part is the network. And so the mixing is very similar to this proxy where you kind of just have a mix server. And then you have many people send their messages in, right? These are just closed envelopes, so they're encrypted for the party they need to go to. And you're gonna have messages go out, except now you can't tell whether this message went through here or it kind of took this path or it took this path, right? And I'm gonna remove some of that clutter maybe, but it's kind of, what it's doing is it's decoupling the inputs from the outputs. So it's doing this mixing when it receives messages. And the way that way you want to think about that also is, imagine that these envelopes are these pink envelopes. And when you open them, you're going to find another encrypted envelope. So you're going to find another closed envelope on the inside. And so what this mixnet will send out is going to be these blue envelopes. So that's kind of a pictorial way to think about that. So that's mixnets. And why are we talking about mixnets is we're going to take kind of a mixnet perspective on Tor. So we're going to see Tor as kind of an instance of something like this. But before that, let's talk about what this networks part of it is, right? So this is the mixing. But where does the network come in? The network comes in with kind of the layers. And actually, instead of drawing this out, maybe we can just look at the lecture notes for a minute. So here's kind of some of the notes on the mixnets. And when I say the network, I'm talking about this thing over here. We have this message, and how are you going to send it through this mixnet network is you're going to kind of do this sort of encryption to have each of the mixing servers just see the information that is pertinent to them. So here we put our message to the secret contact in an envelope and kind of made it clear where that message was going on the envelope so that when, you know, the mix server opens this pink envelope, it gets that information. It knows where to send this blue envelope to. And so that's kind of what's going to happen here is that this first location that this first mixing server that gets the messages is going to pull out the blue envelope and send it across. And then the second one is going to pull out this red envelope and send it across. And then finally, over here, we're going to have the last opening where we actually get the envelope that needs to go to the secret contact. And that's going to be sent to the secret contact. So that's kind of the network part of the mixnets is that you can kind of send things through multiple mixing servers. And the one thing that you want to make sure you understand here is why that's helpful, right? Like, why does it get us anything to send our message through multiple mixing servers instead of the one mixing server, right? Like, what does this extra decoupling do, right? And what Gabe mentioned in class was essentially even if one of these things is compromised and the government kind of gets all of the information that they have, we have this guy who knows where the message was coming from and this guy that knows where the message is going to. But this first server doesn't actually know where the message is going. This one doesn't know where it came from. And this one actually kind of doesn't know anything. And so that's basically what we're getting is we're getting this decoupling. So each of the intermediaries knows less and less about the metadata of this message. Okay, so let's go back to our definition sheet that we're compiling. Don't worry about writing any of this down. Obviously, I'll put it up. And so the next thing to talk about is Tor, and we're going to start talking about it in terms of this perspective. And in Tor, instead of having these like fixed mixing servers that we go through, we're going to have all these nodes between the client and the server. And what the client is going to do is it's going to pick some subset of these nodes to route through and route their message this way. So maybe this is the way the message gets routed. And in your homework this week, you're actually going to generate some Tor circuits. So if you're wondering about the details of exactly how you would pick this circuit, how you would communicate it, you're, I mean, obviously continue listening to lab, that's going to help. But then also you're going to see more about that on the homework and get a much more kind of intuitive grasp of it because you're going to work with it a little bit. And so when we're talking about Tor circuits, we've got now a couple ideas, right? So we have Tor circuits. And what were our ideas? Let's get some ideas in here. And so the first idea was to route the message to an intermediary to break the connection between the sender and the receiver through intermediary. And then the second idea, what was the second idea? Was to enlist more than one intermediary. And then finally for Tor, what we're going to have is we're going to actually pick a subset of intermediaries to route through. So actually having a full network of intermediaries. Right? And so if we actually look at the, maybe what we studied in lecture, we have this sort of thing where it's actually really hard to, what we're doing here is the first idea is to just route through an intermediary. And then actually, even once we're routing through multiple intermediary, there's one step forward we can do where actually we even hide what steps, what intermediaries the client goes through. So here the client is going through this node and then this node and then this node and going to the server. But when you have a lot of different clients that are picking different routes through these set of intermediaries, it's really hard to tell which one is going where. It's not impossible. It's not, the guarantees aren't quite as strong as encryption where we can say like, no polynomial time adversary can do anything bad here, but, and so they're a little bit more ad hoc, and clearly the US government can do something about this every once in a while, but it's pretty good. And we're going to talk about why it's pretty good and what it hides and how it hides it, right? And so one of the core pieces of Tor that, you know, you want to get an idea of what this term means is just a cell. And you're going to have different types of cells. But the main thing to know about cells is that, you know, other protocols, say TLS and so on, have other names for what these units are called that are sent across the wire, like packets. And so that in Tor is just called a cell. And if you understand that, then when you're reading things, when you're hearing Gabe or I talk about it, it'll make a lot more sense what we're talking about. And so there's a few types of cells, and I might put that on the syllabus as well. So we have command cells and relay cells, and the command cells kind of asked to create or build the circuit, you know, create the circuits or extend the circuit or destroy the circuit. And then we have relay cells that actually carry the data that we want to send across. That's cells. And so that brings us to talking about this sort of telescoping connection that we have in Tor. So what is this telescoping connection? What we mean by this telescoping connection is we have these three parties. We have the client, we have relay 1, relay 2. And so if the client actually wants to connect to relay 2, what it's going to do is it's going to, first it's going to create a connection with, so this is the cell, and it's going to say create something. And then R1 is going to say, okay, I created that. And then the party is going to say, okay, R1, can you extend the connection? And this is the telescoping part of it. And so what is R1 going to do when it sees that is it's going to tell R2, hey, can you create this extension or create this connection? And so on and so forth. And so you can imagine why this is called telescoping, is just this building upon each other. So now, maybe you have a way to extend here if you want to connect to a third party. So that's the telescoping connection in Tor. Let me know if there's something in chat, because the chat keeps kind of going away from my screen. But yeah, I don't see anything right now, which is good. Or bad, maybe I've lost everyone already. But okay, so we've got the telescoping connection, and we've actually, even before we see that, we've got to understand why Tor needs its own keys. So that's maybe something that'll go previously, maybe it'll go here. Why does Tor need its own keys? So why can't we just build all of this routing and rerouting through just on the TLS connections themselves? Why do we need extra keys? Why are we encrypting more stuff? So just, there's that. And then let's see. We've got mixnets, we've got why does Tor need its own keys. And so now we're going to talk about Tor metadata. But before we talk about that, maybe we should actually talk about what this kind of onioning is, right? So I'll talk about that through the lecture notes today. And so there's something called onioning in Tor. What does that mean? So this is the telescoping connection in a little bit more detail. Onioning. So onioning kind of refers to this, oh, it's not here, to that kind of opening of envelopes picture that we had before. And so here's another way of looking at it. So if the client is trying to connect, this is what the connection looks like. The client is going to go through R1 and R2 to get to the server. And so the client will actually send this sort of an encryption to R1. And this is onioning because there's different layers of the encryption that'll be peeled off one by one, right? So first, the client is going to send this to R1. And then what is R1 going to do? It's going to look up this C1 to get the key and C2. And then once it has the key, it's going to pull off this like first layer of the encryption, right? It's going to peel the first layer of the onion. And then it's going to send what was inside, obviously with some, it's going to append create C2 to it. And then it's going to send what's inside to R2. And now R2 can look up C2 to get the key that it needs and actually access this cell and then maybe pass the cell on. So that's why it's called onioning, right? So now, R2 can actually build this TCP connection with the server. It can kind of build a TLS connection with the server where the client is now sharing keys with the server. But the important thing that I'm trying to describe here is why we have these encryptions, one layer after the other, why it's called onioning, why it's called onion routing, and so on. So that's onioning. We'll put that in the lab definition sheet. Onioning and what it means. And so now we can move on to Tor metadata. And so, actually, this is horrible handwriting. Let me write that better. Tor metadata. And so the first thing we can be worried about that something about the metadata might reveal that the traffic is Tor, that the traffic is being routed through Tor. And so the things that might reveal this might be the interpacket timing. I'm not sure if the exact kind of process why this second thing might reveal it, but it might be kind of the packet length. And then also we have this set of nodes that we route through, right? So the destination IP or port might actually reveal that we're routing through Tor, right? So like even the first hop node that we have might kind of reveal that we're routing through Tor. And what else can we be worried about when it comes to Tor metadata? The other thing is that the metadata might reveal what website we're accessing. And so here, when we say what website we're accessing, revealing what website we're accessing, we're not actually talking about somebody being able to kind of track all the different nodes of this route through the Tor network. What we're talking about is even if that doesn't happen, if somebody can't just break Tor, how may they be able to reveal what website you're accessing by just looking at the Tor metadata? And one of those things is they could look at the timing of the traffic through the network. And so that over here would look like maybe you're seeing every time I send a message here, very shortly after, there's a message that goes to the blue node, right? So maybe I've built this connection through this circuit, and we're going to have something that looks like this happening very often. And so maybe somebody can understand that the blue node is like the very next step in my circuit. Maybe, you know, if they've watched even more carefully, they can figure out the red node. And then maybe watching this timing, they actually figure out where I'm trying to go. And so that's watching the timing of the traffic through the network. Another thing you can watch is just the timing of the requests themselves. So it can be even just the timing of the request that the client is sending out. So if you just have, you know, if this is the only thing that you can watch is every time the client sends out a packet, is what are the timings of these requests? And maybe you can figure out some pattern, right? So maybe if you're trying to access Facebook, the kind of first access to Facebook has a pattern of the timing of the request. And somebody can watch this and watch the request you're sending out and see if it matches this pattern. And so that might reveal what website you were accessing. So what protections, we spoke about what Tor metadata might reveal. So what protections is Tor actually providing? Right?
Well, among other things, isn't there the packet resizing? Like there's a, well, originally it was like a fixed size packet, and then now there's like some automated like randomization of packet size to try and prevent some of that sort of fingerprinting.
Right. Yeah. So that's actually a really good point. And this is something that when we talk about this like packet length being able to be monitored, it's also a little bit what we might be worried about without some of those mitigations that we have. And so like even just talking about the level at which we know the Tor protocol right now in class, which I'm not sure are those kind of like the packet sizing, is that done in base Tor or is that based on kind of the browser that you're using?
From what I could tell, it seemed like But actually, yeah, I guess I don't know. We were focusing mostly on the sort of traditional Firefox Tor
Hmm.
implementation, and it seemed like there was at least over Wireshark that you could see a certain amount of variation in the packet size. But I haven't actually
Okay.
looked to see if that changes based on what implementation you're using.
Okay, yeah. So that's I guess that Tor kind of hides a little bit of the this connection that we spoke about here then, right? So like revealing itself that the packet is Tor or kind of right, I guess okay, so part of the resizing, I believe actually, I'll confirm this with Gabe, is to decouple these messages. So even if you're kind of watching the traffic through the network, it's so that you can't really say, okay, when I see this happening, as long as you know this node is sending out a lot of messages all the time anyway, even when you see this sort of behavior, if the packet is being resized quite a bit, then you can't actually tell, you know, will this packet definitely be smaller or will it get a bit bigger? That to me seems like a reasonable um, reason to be doing that. And so what do
Yeah,
all of these things, yeah.
because it was fully randomized, or like there's a certain, since the packets weren't necessarily, it didn't sound like they were necessarily pretending to be some other protocol. Sort of
Mhm.
when he was commenting on the people detecting that, like since it is randomized, people could still sort of figure out that this was Tor traffic, but not necessarily, I guess, intuit where that was going specifically. So
Yeah, exactly. So you might still be able to like, even just by seeing the first node, right? If it's a part of that network of nodes, if that, you know, IP port is where you really want to go, to kind of start a Tor circuit, it's one of those um, nodes for Tor, then maybe just seeing that, you know, that this message is being routed through Tor. But I can see why the resizing would be helpful for not figuring out kind of what the exact route is, even if you're watching the timing of the packets that are flowing through the network. And so the two things that kind of I'm getting at here is just like once you have this entire Tor protocol, then like what basic protections is it providing, which is kind of the anonymity of the client to the server, right? So we're trying to fix this issue of access to the internet, but one of the things that Tor is also providing is this anonymity of the client to the server and the hiding of um, destination of the traffic from local sensors. Not this type of sensor, the other type of sensor. Right. So these are the kind of basic Tor protections. But there's more, right? There's more that we learned about in class. We actually spoke about these hidden services. Do we have time left? I actually don't know when that ends. 10:20. All right. Yes, we do have time. All right. Perfect. So the next thing that we were talking about was, you know, we've got this anonymity of the client to the server. How can we get anonymity of the server, right? Hide where the server is. And so this is going to be the Tor hidden services or onion services. And so there's the anonymity of the server to client. So the client doesn't know where it is. And to some extent, this also gives us denial of service protection, right? Because now you can't just reflect traffic at somebody. There's a lot more you have to do before you can kind of get to them because you don't know exactly where they are. And so, how do we do this, right? So, connecting to a hidden service. This is something that's covered in lecture 14, I think. And I'll put some of the details here after, before I put up these notes, but they'll probably be in my notes, my more detailed notes on the lecture. And then one thing I would recommend, if like this is not, the steps of connecting to a hidden service aren't clear in your mind, you can't come up with them, is just go rewatch the lecture. It's so clear in steps, and just write down, what is step one and what is step two, and so on. So if you can kind of make this sort of like a step-by-step guide for yourself of how you would connect to a hidden service, then and write just a sentence or two about it, you're more than good for kind of these like Tor, hidden, or onion services. But let's just talk about what some of the pieces of this are, which is one, in some sense, you're like gluing two circuits together, right? Is you're gonna have the client circuit and you're gonna have the server circuit, and you're gluing them together because now you want anonymity for both. So instead of just the client having the circuit and it goes to the server, now both people are connecting through the individual circuits and meeting somewhere within the Tor nodes. So you're going to be gluing two circuits together. Um, the other kind of terms that you should know or that should make sense once you understand these steps is introduction points, which is points through which the client can contact the server, the rendezvous point, which is going to be the point that the client kind of chooses to ask the server to meet it at, and then how the domain name is decided. And so the domain names, the fact that they're key dependent. Right. And so that actually brings us all the way through to the end of lecture 14. And then for lecture 15, there, I believe, are a couple more points that Gabe already has on this document. And once I've watched lecture 15, which is probably going to be this weekend, I'll probably add that a little bit to the document, and I can speak to it a little bit if anybody wants me to, like put up a video or something. And I'll have my notes up for lectures 12 and 13 probably today. I'll probably put these definitions up today, or I'll add this to the kind of things you should know from lecture note that I have put up. That might take till tomorrow because I still have to organize this. Right. And so that stuff's going to be put up. And I hope that this is helpful for getting an overview of what you should learn from the Tor chapter, and kind of getting a much like a bird's eye view